All right, gentlemen. All right, whoever this John Doe is, I'm about to remove him. If you let me get everybody in here first before I do that. So I have a broader scope. All right, gentlemen. Oh, what did I hit? Almost missed him. I don't even know how I did that. All right. All right, let me see. Hang tight, gentlemen. Come on. All right. So I do have one in the waiting room. He has a random name I don't recognize. Let me tell him. Let me send him a message really quickly. Let me see message. Um, show your official. Huh. Let's try this. See that. I'm coming. Yeah, there's just a name I don't recognize. So I feel like if I remove him, it like won't let him back in. Let me see this one. All right. It's like I don't know if you guys are changing your names when you leave. I'm gonna just boot this person. No, don't report. I want him to be able to join back. I'm gonna just leave him in the waiting room. I don't know, but if you okay, so I was trying to wait till I got as many of the students in the chat, or in the class. If you know you have a brother that's in the waiting room, and if they aren't showing their student name, I'm not gonna let them in. So if you can get a message to them, because I put a message in the chat, but I don't know if you guys see this kind of stuff, but let them know that they need to change their name to show their Morehouse student name so I can let them in. Otherwise, because I don't like letting random people in, because sometimes it'd be like weird stuff. Let me see. So as far as announcements, so exam 2 was due this morning at 9 a.m. Keep in mind with any of our assignments, we can work on them past the due date for a 10% late penalty. I just finished pulling the grade. I was waiting for like that I was waiting for exam 2 to be done, right? So for it to be due this morning before I calculated midterms. So I went on and did my 9 a.m. class, and I literally like that's part of the reason why I was a little bit late. I finished at least crunching the numbers or like pulling the raw data for your midterm grades. And so the midterm is going to include exam 1, exam 2, the quizzes from weeks 1 through 7, like weeks 1, 2, 3, and 5, 6, 7, and the homeworks from weeks 1, 2, 3, 5, 6, 7. So my 9 a.m. class, let me make sure. Can you guys hear me okay? My 9 a.m. class, they were like, hey, Mr. Pfeiffer, we couldn't get those interactive figures to work during the exam. So I went back and looked at it. So any question, it was like 10 questions out of a total of 27 that did that. So those 10 questions that had the interactive figures, I just removed them. So you essentially got credit for them. So just work on everything else if you haven't done so already. I didn't crunch the numbers. Like I said, I just pulled the raw data, but I saw a lot of people were missing stuff. You definitely want to go ahead. Hang tight, hang tight. Let me finish. I'm coming back. I just muted you so I can like focus. But you definitely want to go ahead and submit those things. Let me see. Yeah. You can keep working. You can keep working like on stuff. anything, exams, quizzes, homework. It's all available with a 10% late penalty until like that first week of December. That's when final exams start. I really want the final exam to be the last thing. So I'm trying to get everything, whatever you want a grade for on Pearson. And if you are like having to go back and submit assignments, my recommendation is get your exams in order first. That's the least amount of work with the most points. The exams altogether are going to total like 80% of your grades. The quizzes altogether are only 10%. So there's a weekly quiz. Those are like 5 questions, but that's 10% of your grade. And then homework is only 10% of your grade. That's like the most work for the least amount of points. So to be savvy with your energy, if you are having to go back and make up missed assignments, I would make sure the exams are in order first. That's like 80%. That's the bulk of your grade right there. Let me see if there's anything else. So yeah, those interactive figures, I just removed those. I pretty much gave everybody credit for those questions. Okay, so yeah, I know someone was on the audio for a hot second. I'm not sure who it was. If you want to come back, there's no worries. It's still available. Yeah, so it's still available. So yeah, yeah. Well, so what I ended up doing at first, I thought I couldn't do this, but I was able to go back and just remove those questions. So like if you've already submitted that exam, it just gave you credit, and if you're redoing it, it won't even show up. So it's pretty much like those questions weren't even there. Yeah, that's the gist of it. Yeah. So and it worked because I had some students that before I removed those questions, they were maybe like a 70 or whatever, and then after I removed them, some of them got to like almost 100, like 98, 90, whatever. So, um, so yeah, it's possible. Just keep working, and again, the main thing is you want to make sure those exams are in order first. Let me get this student, and so yeah. So like if you have questions, I am monitoring the chat, or either I'm probably going to suppress my audio so I can focus because like the pings and dings are like distracting. This morning, with my earlier class, I started to stream section 2.1, but I guess my internet went out, so I had to just scrap that one, and so I'll be starting fresh with section 2.1 now. Okay, and again, if you have questions, comments, or concerns, so I'll be like I said, I pulled the data, the raw data with those removed questions from exam 2. I pulled that raw data. I have their data for exams 1 and 2, basically any quiz that's been due and any homework that's been due. I haven't crunched any numbers yet. I'll do that. I'm trying to get it by the end of the day. I have classes all the way up until like 5 p.m. But you know, but I have the data. I just want to crunch it and load it and submit those midterm grades so you can at least see where you are. And then another intent that I'd like to do is I want to reach out to those like, okay, that was clearly missing. Like say, hey, are you still here? And like if I don't hear from you, then I had to like boot you. But I'll reach out before I do anything like that because I just want to make sure that people are doing what they need to be doing. Okay, so I'm going to suppress my audio and let me see. So what we're doing today, so we're moving into chapter 2. Now, this next phase, I mean, it's going to be over in a blink of an eye. We only have like 5 sets of new material to go. That's only 5 weeks. So for instance, this is the top of week 9, right? So we're starting chapter 2. We're only doing 3 sections in chapter 2. So it's 2.1, 2.2, and 2.3. So this week is 2.1. Week 10 is 2.2. Week 11 is 2.3. Week 12 is exam 3 over chapter 2. And then week 13 and 14, there's a couple of more sections there. And then we're pretty much at the final. It'll be over quickly. My recommendation, you definitely want to get Pearson in order like now. If you try to wait until like the end of November to do that stuff, what happens, the closer we get to the final, the more unreliable Pearson is going to be. It seems like, I guess that, people are using it, whatever their scope is, it seems like everybody tries to rush at the last minute and get on Pearson and submit that stuff. And it just becomes unreliable. the server's down. I mean, like this is on Pearson's end. This isn't anything that we have control over. Only thing we haven't control over is how early we start, right? So again, I'm not only other thing that I'm going to be adding on Pearson is exam 3, and I think there might and a portion of the final exam. We'll talk more about the final when we get closer to it. There is a common final exam. Yeah, we'll talk more about that as we get closer to it. But for right now, you know, everything is on Pearson that you access through Blackboard. Okay. Can we get that to go away? Yeah, that's better. Okay, so we're moving into chapter 2. Are you lagging? Let me see. Seems okay. It's a little bit of a lag, but chapter 2 is concerning polynomials and rational functions. And so we're going to start this off with section 2.1 Quadratic Functions. Some objectives here are that we'd like to graph a quadratic function in standard form. We'd like to graph any quadratic function and solve problems modeled by quadratic functions, right? I am watching the clock. Let's see. So a quadratic function is a function of the form that you see here. This f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. This is called a quadratic function, right? So notice that the highest exponent on any variable is a 2, right? And you know, so we've kind of explored this. We've introduced this before when we were talking about the library of parent functions. So that was like y equals x squared. It was basically a U-shaped graph. So now we're going to be exploring some other properties and characteristics of quadratic functions. So a quadratic function in this form, where we have f of x equals a times parentheses x minus h quantity squared plus k with a not equal to 0. This is a quadratic function in standard form, right? This is standard form. The graph of f is a parabola with the vertex h comma k, and the parabola is symmetric with respect to the line x equals h. Is called the axis of the parabola. If a is positive, then the parabola opens upward. If a is negative, then the parabola opens downward. So in this standard form, you know, we can use transformations to graph the quadratic. We've discussed that, you know, like, so the basic shape will be a U-shaped graph with the vertex at the origin, and then this h tells us if we're going to move either left or right. I don't know why there's such a delay. Let me see if I can, what if I click here? But the h tells us if we're going to move left or right. The k tells us if we move up or down. This tells us our distortion. The a tells us our distortion, or if we flip vertically, all right? So the a is like our leading coefficient. If the leading coefficient is positive, then the parabola opens upward. If the leading coefficient is negative, then the parabola opens downward. Okay. So here we're asked to find the standard form of the quadratic function whose graph has this vertex and passes through this point, right? So this is the vertex. That means that this is our h comma k of the parabola, and it's passing through some point x comma y. All right. So the standard form of a quadratic we just had on the previous slide is f of x equals a times x minus h quantity squared plus k. All right. So let's plug in what was given. So then h is -3. All right. So here, let's start with the f of x. F of x is our y. So y is 7. So we have that y is 7. They didn't give us the a. X is -4 minus h is -3. Okay, so you have to be careful with your parentheses there. And then the k is 4, right? I just plugged in those numbers into the formula. The standard form of the equation of a quadratic, right? So we have one equation. There's only one piece of information that we don't know. I need to speak to the student. So, well, we'll talk about that once I get those grades up there so you can see. Okay. So then if we simplify, now here we have a negative minus and -3, so that's a double negative. Double negative becomes positive. So then negative 4 plus 3 ends up being negative 1, right? So the 7 comes down, the a comes down. We have negative 1 squared plus 4. Negative 1 times negative 1 is positive 1. So then we have 7 equals a plus 4, subtract 4 on both sides, and we get that a equals 3, right? So then if we want the standard form of the quadratic with these features, that's gonna, so now we plug in our a, our h, and our k. So then we're gonna have f of x equals 3 times x. Now if it's minus a negative 3, minus a negative 3 is a double negative, so it's the same as x plus 3 squared plus 4. Okay. Let's do like this style. So on a random note, I did watch Squid Games. I went on and watched it. I got pulled into it somehow. It was interesting. I enjoyed it. I didn't really enjoy the gore, but the story was interesting, to say the least. Okay. So this is what we get. 3 times x plus 3 squared plus 4. And here's a type version of what we just did, all right? So, they started with the standard form of a quadratic. I think hopefully you have a notebook where you're kind of keeping track of your work and you have a formula sheet. I would add this to the formula sheet. So the h in this case was negative 3. You see it here. Notice the use of parentheses. And then they plugged in the k, which is the 4. Then they got here. Then they wanted to solve for a, so they plugged in the given point. So x was negative 4 and y was 7. And then ultimately you can, through algebra, you solve and get a is 3. So then I think they got the same thing that we got. Okay. So here we asked to sketch the graph. We have f of x equals negative 3 times x plus 2 quantity squared plus 12, right? So I'm going to start with some graph paper. This is just a graph paper that I had from earlier, so I'm just going to use it before the internet kind of went out, right? So, so we're asked to graph. We have this negative 3 x plus 2 quantity squared plus 12. So this is the standard form of the equation of a quadratic, right? So in this form, they actually give us the vertex. Remember, we should rewrite it in the proper form. This f of x equals negative 3. That's going to be, it has to be x minus h, so you have to rewrite it as x minus a negative 2. That's how you can see the proper h. So then the coordinates of the vertex are negative 2, 12, right? So let's go ahead and plot that. So if we go to negative 2 and 12, and let's do this paper, we'll do better with this. So negative 2 and 12 is here. Okay, so that's the vertex. So then one property of parabolas is that they have this axis of symmetry. The axis of symmetry is going to be the x-coordinate of the vertex, right? The x-coordinate of the vertex, right? So that's going to be x equals negative 2. So then what I want to do, I want to just identify that axis of symmetry. And let me go style. Let's do like this. Let's do this one. That's okay. Okay. I think that's better. All right, so this is our axis of symmetry. So what this means is that whenever we get a point on one side of this axis, we automatically get a point on the other. Right there. Okay. So for instance, say we plug x equal to negative 1 into this formula, right? So when x is negative 1, I'm just going to kind of do it quickly. Negative 1 plus 2 is 1. 1 squared is 1. So then this is just negative 3 plus 12, which is 9. So when x is negative 1, y is 9, right here, actually. Copy, paste. So -1 and 9 is here, right? But now notice we went 1 to the right of this axis of symmetry. That means we can also go 1 to the left of the axis of symmetry and we get another point. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, right here. So what that means is that when x is -3, y is also 9. If you don't believe me, you can plug it in and verify that it works, all right? Let's do when x is 0. So when x is 0, let's see. So 0 plus 2 is 2. 2 squared is 4. 4 times -3 is what? -12. -12 plus 12 is 0. So when x is 0, y is 0. So that means it passes through the origin. But now what this means is if we go 2 to the right of this axis, we're at 0. That means also if we go 2 to the left of this axis, we're also at 0. So if we're here at -4, 1, 2, 3, right here, right? And it'll basically, so again, whenever you get a point on the right, you automatically get a point on the left. And then you can like connect it with a smooth curve. I'm gonna quickly do when x is 1. When x is 1, that's 3 squared is 9 times 3 is a -27. What is that? 8 and 7, -15. That goes off my chart. So I just need to go off the chart before I get to 1. So we'll get something kind of like this. And then, you know, because I can, let's go here. We know this goes there. Okay, that's good enough, I guess. That's the gist of it, right? And then, let's try that again. Let's copy, paste, undo, copy, paste. Come on. Okay. Okay. So I'm watching the clock. I wanted to do one smooth stream. I might go over the time. I'll announce. I'll do the best I can to announce. You know, most of the time you can go, but I might have to. I'll probably just keep streaming because I just wanted to do one smooth stream. Right. So let's verify this with like a graphing utility. Let me see if I can pull up my trusty dusty rusty. Come on, let's see. All right. I agree. Choose the file. Browse. I gotta think about where this thing is. Shyster. Do I have it here? I might have it here. Here. Maybe I got it somewhere else. Hang on, I'm just trying to find my emulator. It keeps like, I don't know why it keeps going out. Let me see. I think it's this one. That's not the right one. Is it this one? Let's try another one. I'm coming. Give me just a moment. Let me try this one. That's a pain. Okay, let me try it here. Because I know where it is. It's just forcing me to like sign in. I gotta find it. is going to be, I'm coming, guys. Choose the file. Let me see. Nope. Here. I'm coming. Is here. Ugh, that's a pain. Okay, give me a moment. Give me a moment. This is what I was trying to avoid. Here, let me do like this real quick. I'll be right back. All right. That's okay. Let me see. Okay, well that wasn't as bad as I thought. We were here. Okay. And then like this. Come on. This is all I want. Yeah, that's what I'm trying to get. Okay. Let's see. ABC, where is it? Here it is. Okay, that was an adventure. Let's try one more time. Browse. Was that not the right one? I thought that was it. Okay. I'm gonna try this one. Oh no. Come on. Yeah, technology has been just getting in my way all day. I don't know why it's not loading. Like, I don't really have a good browse. Come on. I don't want to open that. Okay, let's try this here. Let's see. I think I tried that one already. Let's try this one. Okay, let's try a different one then. This one. It's not that one. It's one of these. That sucks. So I can't get my email. I don't know why it's not working. Let me try one more time. Browse. It might not be there anymore. Let me close this out. It should be like that one. Yeah, I can't get it to work, and I don't know. That sucks. Because it's been working all this time. Let me try this one. Okay. Well, I guess I have to forego it now until I can get it back operational. Browse. It's not that one. Let me try this one. But I think I tried that one already. Okay, give me one more moment. I'm gonna try one other thing. Let's go like this. Close that out. Let's do another one. Let's try it here. It should be here. And I know one of these works. It's not that one. Let's try. First, it should have been this one. And if it's not that, try one more time. Yeah. Okay. I guess I just need to get another ROM. I don't know why periodically like it just stops working. And I thought I had like isolated the working one, but I guess I didn't. Because it should be this, but that's not working anymore. From the calculator. Yeah. Okay. Well, I had to figure that out later. I can't get it to work. I don't know why it's not working. Sorry about that. Yeah, it's weird because it's like it's worked in the past and it's been working. I've been using it for years, and now all of a sudden, it doesn't want to work. But that's how these things go. I mean, I could use. Oh, and let me get this back to the proper view. There it is. Okay. Okay. Let me see if the stream is still going. That looks like it's okay. Okay, sorry about that. So I couldn't get it to work. I'll have to just figure out why it's not working. Now we could. I didn't try like we could do like GeoGebra or Desmos. I think I've done demos on those. I was just trying to do one in the graphing calculator, but like I said, I couldn't get it to work. So we'll have to try that a little bit later. So we saw when we did it by hand. Let me go paper and get rid of these lines. Right? We got something. We got an image like this. Notice the leading coefficient is a -3, right? So that tells us that the parabola opens downward. The y-intercept is, wait a minute. Something's not right. Oh, yeah, no. Let me think about it. Yeah, I think this is okay. Yeah, because that's the coordinates of the vertex. Yeah, so we're okay. Okay, let's keep going. So this is like a typed up version of what we did. It says the parabola with the leading coefficient is -3 and the coordinates of the vertex is -212, right? Then they found the x-intercepts. All right, so they calculated x-intercepts. We got lucky because it kind of like fell on there cleanly or evenly. And the y-intercept is 0. So they found the x-intercept, y-intercepts. So they had the vertex and they found the x and y-intercepts. And then they kind of went from there. Okay, but you see they got the same thing that we got. Okay, let's try another one. So let me add a page. Let me see the time. I know we're just about out of time. Let me at least try this one. And actually what might help if I just copy, opens up. Let me copy this one, copy. I want to paste it right there. I can get rid of this. Let's go like this. All right, and then I need a copy of this graph. All right, so we're asked to sketch the graph of this. So let me get a copy of it. I can get rid of this, delete, paste. And then we're going to get rid of the stuff from the previous example. This stuff, and then this. I can't separate those. Okay. Let's see. Now, in this form, this is what the general form of the equation of a quadratic. This already tells us the y-intercept is -10. So we could write this in standard form. We have this 2x squared plus 8x minus 10. Let me think. We would have to use completing a square to do that. So let's just do a quick demo on completing a square. All right. So we have f of x equals 2x squared plus 8x minus 10. And we want to use completing the square to get this in standard form, right? So the first thing is that the leading coefficient needs to be a 1. So we're going to factor out 2 from everything. So this is going to be the same as 2 times, now we have this x squared plus 4x minus 5, right? We just factored out 2 from everything. So then completing the square now we do is going to be, we're going to say plus or minus b over 2 squared, right? So right here we're going to say plus b over 2 quantity squared, and we're going to say minus b over 2 squared. So we're essentially adding 0, we're just manipulating the form, right? So if we incorporate this, we'll get, let's see, x squared plus 4x. So then that's going to be plus 4 over 2 squared, and then we're going to do minus 4 over 2 squared, right? So completing the square. And again, we're using completing, I'm going to just abbreviate the square. Okay. So then if we keep going, 4 divided by 2 is 2 squared is 2, so we're saying plus or minus 2. So this gives us 2 times, then we got a plus 2 and a minus 2. And again, if this isn't clear, you want to just look up how to complete the square. Let me make sure he's in the other class. He's probably in the next class. Oh. Nope, he's in this one. All right, I'll let him. Okay. So now if we look at the first 3 terms, like the first 3 terms, we can factor, let me think about it. B over 2 squared. Oh, 4, sorry, plus or minus 4, right? Because 4 divided by 2 is 2. 2 squared is 4. So that should be plus or minus 4. So now if we look at the first three terms, we can factor them. I think they factor into the following. Let me add a page. And let's do the view. I see the time. I'm about to let you guys go. So now, this is the same as the first three. I'll separate it like this with that green bar. X plus 2 squared. So that's the same as x plus 2 quantity squared. All right, we can factor it into that. And then we have that negative 4 minus 5 is negative 9. Right? Notice my use of parentheses. We still need to distribute that 2, right? This 2, this leading coefficient, we need to make sure it's accounted for. All right, so then when we finish, we'll get that f of x equals 2 times x plus 2 squared. 2 times negative 9 is minus 18, right? So this tells us that the coordinates of the vertex are h comma k is going to be negative 2, negative 18. Okay, so that one's that's the, we need to be like in quadrant 3. Let me see. Okay, I might use the one that's already prepared for the sake of time. And it opens upward. We can do it. Let's just knock it out. So negative 2, negative 18. We could go and find the x-intercept and the y-intercept. Usually when I do that, I usually like to do the y-intercept first. That's usually a lot easier. We have 2x squared plus 8x minus 10. Let me see. There it is. Let me get a copy of this. Let's just quickly find the x and y intercepts. Let's copy, paste. And let me highlight this so we don't lose track of it. So now, I usually like to start off by finding the y-intercept first. I feel like that's a lot easier to do than, oftentimes it's easier to do than the x-intercept. I'm watching the clock. So to find the y-intercept, we want to set x equal to 0, right? So then if we set x equal to 0, we're going to get negative 10. You should be able to quickly find that, right? And then for the x-intercept, again, we're going to set y equal to 0, right? So what I'm going to do, let me think about it. Okay, that's fine. We'll just use that. I mean, yeah, that's fine. I mean, we've kind of already done it, but I'm going to just do it like this. 2x squared plus 8x minus 10. I want to set it to 0. We can divide both sides by 2. We'll get x squared plus 4x minus 5 equals 0. Then we want to see, can we factor this into some form like this, x and x. One's plus and one's minus. I think it's a positive 5 and a negative 1. Notice that 5 times negative 1 is negative 5. And then 5 plus negative 1 is a positive 4, right? So then from here, we get that the x-intercepts are x equals a negative 5 and a positive 1, okay? Negative 10. And then the vertex, again, we found earlier was negative 2, negative 18. So we can put all that together. Did I lose a page? Where's my page? Okay, let's go like this. Let's add another page, okay? I'm gonna try to do a quick graph. I'm gonna get you guys out of here. I got like 2 minutes. Let me see. Negative 2, negative 18. All right, so say this is the origin. Let's go 2, 4, 6, 8, 10, 12, 14, 16, 18. Here's 20. I'm gonna go up by a couple. I'm gonna go 1, 2, 3 should be enough. 1, 2. I think that's gonna be good because I'm just kind of rushing. Okay, we'll go with that. Let me move all the stuff over a little bit. So this is the positive x. Oops. This is positive x in this direction. This is the positive y. This is the origin. This is 1, 2, 3. 1, 2, 3. These are negative values. We went by 2, 4. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These are all negative values, right? So let's put all these components together. So let's start off with the vertex. We got the vertex was -2, -18, right? Paper. I see the clock. I'm about to let you guys go. I got like exactly a minute. -2, -18 is here. Right here, it looks like. All right. That's the point, -2, -18. Okay. Let's see, what else did we get? We got the Y-intercept was 0, -10. So now we do have this axis of symmetry. We could use that as we kind of go about it. A little style, like this. That's a little bit better. So if we went 2 to the right, and we're at -10, so that means we have a point here. That means also if we go 2 to the left, so if we're at -4, which would be here, let's see, how many dots? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, right here. Right? So on and so on. And then we got -5, so I probably should have did a better x-axis, but that's okay. We have 1 here and then 1 way off to the right. And so if we put all those together, my drawing is way off. Come on. So essentially something like this. And I'm trying to get you guys out of here. It's, because I'm trying to use this thing. That's the only thing that's kind of throwing it off. Let me see if I go a little bit more like this. Then stretch it. It's a little bit better. Okay, I'm gonna just, let me see. Okay, I'm trying to get you out of here. I don't know how to get that to behave the way I want it to. But you get the gist of it, I think. I mean, if I did something like, okay, so what is that, -5? Let's see. There's 4. 5 would be like here. I think if I put it on the money, it'll work. Like that goes there. This goes here. I think that was there. Okay, that'll work for now. And then the idea is this. It basically continues the pattern, right? We just ran out of time, just trying to rush. But again, you can put these things in like graphing calculators. Let me just quickly compare it to the type, and then I'll let you go. Let's go paper like this, because I do need to kind of get my next class in here. So we did it by hand. We explored some concepts. Okay, they use the vertex formula. So the vertex formula is -b/2a. Just really quickly. So I'll probably mention that for my next class. -b/2a. and that gives us the x coordinate of the vertex, and then you use that to find the corresponding y. And long story short, you get a graph similar to ours. Okay. Paper, no. Yeah. Single page. Okay. So let me kind of get ready for my next class. All right, guys. So I'm going to keep the stream going. I'm going to get set up for my next class and try to finish this out. And all right. So, but we've talked about the adjustments for exam 2, and enjoy the rest of your day. All right. And you're welcome to stay or leave, whatever you feel like you need to do. Let me get ready for my next class. Let's go like this. Let's go here, like this. Where, what, 3 p.m.? Which is this one. Cool, okay. So we have this student in OP. All right. Okay. Oh, everybody's getting here now. So for the students that are just joining, I'm going to go ahead and try to wrap up. This is section 2.1. I wanted to do the best I can to try to wrap up the stream. There was like a huge gap where basically, just fooling around with technical difficulties and stuff like that. But I want to at least try to get at least one stream, one clean stream, more or less, of this section. Thank you. So just let me finish this and I'll give you some updates. I don't have that many more slides to go, so I'm actually almost done. So this section, we just wrapped up an example on graphing quadratics, and we explore some other concepts. In the past, when we talked about quadratics, we introduced it when we were talking about a library of parent functions, and we use transformations. It's the U-shaped graph that you see on the screen now. So today we explored like the standard form of a quadratic. So you're gonna have to go back and watch those videos, and we'll talk about it. You have to kind of catch the flow for right now, and we'll kind of keep doing it. We're gonna devote this week to this section, and we just introduced this concept called the Vertex Formula. So given the formula for a quadratic, the Vertex Formula is the negative b over 2a. You'd have to go back and watch the video to get all the details, but we're gonna kind of continue here. And like I said, I'm almost done with the presentation, so let me kind of wrap it up and then we'll come back and do what we need to do. Let's see. So in this example, it says the graph of this quadratic is shown. We're asked to find the domain and range and then solve this inequality, right? So domain and range. So you guys should be able to handle this with what we've talked about before. Domain, let me get the student. Come on. Cool. So domain of a graph is going to be the very left to the very right, right? So looking at this, notice it's a U-shaped graph. It's a parabola. How far left do you think it goes, right? So the far left. Notice the arrows on the bottom mean to continue the pattern. Let me get the student. Continue the pattern, right? So the far left is going to be negative infinity. No matter what x you choose going to the left, there's a corresponding y value. So you do kind of have to use your imagination a little bit. So the far left to the far right is all real, so it's negative infinity or positive infinity. And then the range is the very bottom to the very top. So how far down does this graph go? The very bottom is negative infinity. And then the very top, let me come over here, I guess. It goes up to y value. What's that y value at the top? 3? So it goes down to negative infinity, and the very top is here, is y equals 3. So the range goes from negative infinity to 3. So then it asks us to solve the inequality. We have this inequality is greater than 0, right? And we got lucky because they kind of gave us the x-intercepts. You can see it. It says like the 4 minus square root of 6. So this is it's saying when is this quadratic positive? But notice that this quadratic is f of x, and f of x is our y value, right? So basically, this is saying when is the y value positive, or when is it greater than 0, right? So the y values are positive between the x-intercepts, right, for this region here. So as x goes from the left x-intercept to the right x-intercept, so that's going to be the solution. So between those x values, that's when the quadratic is greater than 0. Now let's see how to find it. Let's find it algebraically, right? We're just looking at the graph, but let's solve this algebraically. Let me see. I think I might have enough space. So if we have, this is a little bit involved, so just kind of brace yourself. Negative 2x squared plus 8x minus 5. We want to know when is that greater than 0. So what we want to do, we want to factor this. We want to see, can we factor this into a factored form? Get this student real quick. We got this one. And I'll give you guys some updates on like midterm grades and things of that nature momentarily. Like I'm just trying to wrap up this section and then we'll come back. So now, let's see, can we factor this, right? But there's no greatest common factor. So I'm going to use this technique called the AC method of factoring. My A is the negative 2 and my C is the negative 5. So if I multiply those, I get a positive 10. All right, I'm going to do this in purple since this is my own, kind of my own technique. All right, so I'm looking for two numbers that multiply to give us 10. And wait a minute, do we have two numbers that do that? I don't think we can factor it that way. We could use quadratic formula. Let me think about it. We can use quadratic formula or completing the square. I was trying to avoid completing the square because it gets a little bit involved. Those are the x-intercepts. So let's just use the quadratic formula. I think that's going to be the simplest way. I just did a demo on completing the square, and we can do it here, but I don't want to like scare you guys, right? So I'm going to use the quadratic formula. Quadratic formula, because I'm just trying to find the x-intercepts. So quadratic formula is, let's see, x equals, let me see, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. One of my students of the past told me that story, and I was like, crap. It was like locked into my mind. So that's how I remember quadratic formula. Let me do that one more time. All right, this is how one of my students remembers that formula. So for the quadratic formula, he goes, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. All right, quadratic formula. Okay. Yeah. I'm going to talk about those interactive figures from the exam. So just give me a moment to kind of wrap this up, and then I'll tell you what I did with that. So then from here, we see our A is negative 2, our B is 8, and our C is negative 5. So then if we plug those into the quadratic formula, so that's going to be negative 8 plus or minus the square root of 64 minus 4 times negative 2 times negative 5 all over 2 times negative 2. Right? So if we keep going, let's see, 4 times 2 is 8. 8 times 5 is what, 40? 64 minus 40 is what? Is that 24? Positive 24? Over negative 4, right? 24 is what? 6 times 4. So that's 2 times the square root of 6. 2 times the square root of 6 over 4 over negative 4. So then we ultimately get, we can divide everything by negative 2. Let me see. So we get 4 plus or minus the square root of 6 over 2. Yeah. That's what they got, right? So those are the coordinates of the X-intercepts. Let me let this gentleman in. Is there a female in this class? One of those names look like a female, but I don't really know because I don't see like faces in my presence. I'm not really sure. I could research and look it up, but wasn't sure. One of those names looks female. Because I hate to address, like, not acknowledge the female, because then it's like, all right, gentlemen, and there's a female in the group. You know, and I don't know about pronouns, and I don't know anything about other stuff. I'm just taking attendance real quick. Because then it opens up to, like, well, are there men that, like, identify that have different pronouns? And, like, if you're referring to the group, you know, like, what's the protocol or etiquette for that as well? Like, that's a whole thing. Like, how do you address? Because in the past, you know, you would just say ladies and gentlemen, but I don't know what the updated Hughes. Sorry. I try not to say you guys' name, but sometimes, you know. Okay, letting people in. Yeah, so we kind of just used the graph there. We saw that the y values were above the x-axis between the x-intercepts, so we found the x-intercepts. We used the quadratic formula. We could have used complete and a square. We tried to factor it initially, but we were not able to factor it. If you're just joining us, I'll give you an update on what I did for exam 2. I'm just trying to finish out the section 2.1, and I only have like less than 5 slides remaining. So then I think here we have a type version of what we did. So the domain, I think we identified that. The very left to the very right was negative infinity to infinity. The range being the very bottom to the very top was negative infinity to 3. Notice the 3 has a square bracket because we actually reach y equals 3. Good afternoon, everyone. And then the graph is above the x-axis between the x-intercepts of 4 plus or minus square root of 6 over 2, right? We use the quadratic formula to find those x-intercepts, right? So when you're trying to solve a quadratic, like say you can't factor it, you can always use a quadratic formula or complete in a square if it has a solution. Okay, we're just about done. Okay, so this is an application. So what we've been doing, we're wrapping up section 2.1. I kind of started with my previous class, and I just continued the stream as you guys joined. I think this is the last example. I'm going to wrap this up, and then we'll go back and kind of fill in some things. Here we're asked to find the dimensions of a rectangular garden. Okay, let me draw a picture. Well, first let's read it. Find the dimensions of a rectangular garden of maximum area if the perimeter of the garden is 80 feet. What is the maximum area of each rectangle? Let's do this again. Let's look at it again. So we're asked to find the dimensions of a rectangular garden of maximum area if the perimeter of the garden is 80. What is the maximum area of each rectangle? That each is the only thing that's throwing me off. But anyway, so the basic shape, right? Basic shape is what? It's a rectangular garden. All right, so we have a rectangle. That's fine. So let's say this is our x and this is our y. Rectangular garden, maximum area. We want a maximum if the perimeter of the garden is 80. So we're given that the perimeter is 80 feet. All right. So let's put this together. So if this is x, that means the top is x as well, and this side is y if it's a rectangle. Let me get the student. All right. And again, I'll give you an update on, I'm aware of exam 2. I'll give you an update about that momentarily. Let me finish out this example, and then I'll give you an update. So now, what's the formula for perimeter? I don't know. None of my words are getting out today. It's just one of those days. So there's no real set formula for perimeter. Perimeter is more of a concept, more so a concept. Perimeter is basically the distance around the outside, all right? I don't know if you're a gamer or not, but like, they say, set up a perimeter, or like I know a lot of like SWAT and tactical units like use that kind of lingo. But basically it just says, it's talking about the outside, right? Perimeter is the outside. So the perimeter in this context is the distance around the outside, so we just add up the outside pieces. So we have x plus x gives us 2x. Y plus y gives us 2y, and that should total 80, right? So let's get this. Let's solve for y. All right. So if we solve for y, subtract 2x on both sides, we get 2y equals negative 2x plus 80. Divide both sides by 2, and y equals negative x plus 40. Okay. So we got that from perimeter, and then the area. Now we want to maximize the area. So we want to find the max area. Here, let's do it like this. We want to find the maximum area. Area in general is length times width for a rectangle, right? So it's x times y. But we just found an equation for y. So let's take this and plug it into our area formula. It's going to be x times negative x plus 40, all right? So then if we distribute, we get negative x squared plus 40x, all right? So we want to find this max area, all right? So we have this quadratic. Let me get a student. Okay. So we have this quadratic. If we were to graph like a equals negative x squared plus 40, it's the highest exponent is a 2, so that means it's a U-shaped curve. It's cool. It's okay. It's a keeps it it's kind of distracting. Give me a moment. Oh, got this student. Let's see. So it's a U-shaped curve, and the leading coefficient is negative. So that means the U opens downward. So that means we're going to have a maximum value, right? The max is going to occur at the vertex. So we can use the vertex formula. Let me write the vertex formula. Vertex formula of a quadratic. So the vertex, the h, which is the x-coordinate of the vertex, that's going to be negative b over 2a. Yeah. All right, negative b over 2a. Let me give myself some space. Let's go paper. Let's do group paper, and then let's do seamless. Okay. So again, the x-coordinate of the vertex is going to be negative b over 2a, right? So we are working with this. We have this area formula, this a of x. We have this negative x squared plus 40x, all right? And we're saying that the x-coordinate of the vertex, let me write it one more time. For the vertex, which is our h, that's the x-coordinate of the vertex, is going to be negative b over 2a, right? So in this example, our a is negative 1 and our b is 40, okay? This looks okay so far. So then this is going to be negative 40 over 2 times negative 1. So it looks like it's 20. So it looks like the x-coordinate of the vertex is at 20. So then the k, which is the y-coordinate of the vertex, is going to be f of h. So whatever solution we got, we plug it into the function to find the corresponding y. So then we're going to get negative 20 squared plus 40 times 20, right? If you do orders of operation, for this first term, we have to decide between multiplying by a negative 1 or handling the exponent. In order of operation, please excuse my dear Aunt Sally's last request. We do exponents first. So 20 times 20 is what, 400? So ultimately that's going to be a negative 400. 4 times 2 is what, 8? So that's plus 800. It looks like we finished with 400. Okay. So then the coordinates of the vertex looks like it's 20 comma 400. Okay. Find the dimensions of it. Okay. So yeah, so we're saying that the area, if we were to graph the area function, it's going to be a parabola, a U-shaped curve. It's going to open downward because of the leading coefficient here, right? So then the area is going to be maximized at the vertex. So the vertex occurs when x is 20. The maximum area is 400 feet squared. So then if X is 20, now we need to go back and find Y. Okay. So then earlier we said that, oops, I want to redo. Earlier we said Y equals negative X plus 40. So then that's going to be equal to negative 20 plus 40, which is 20, right? So it looks like the rectangle is basically a square, 20 feet by 20 feet. So it looks like the max area of the rectangle has these dimensions, okay? So this is us just kind of talking through it and working through it. Let's see how did the text do it. Okay, paper. And then I can give you guys an update on exam 2 and things of that nature. Paper, no, not paper. Okay. So we got a result of 20 by 20. So it said let X be the width. Oh, let me let the student in. Okay. So it says let X be the width and Y be the length. So the perimeter is 2X plus 2Y, which was 80. So then they solve for Y like we did. We got negative X plus 40. They got 40 minus X. It's the same thing, right? So then the area is given by length times width, so X times Y. So I think we got that same thing. So then the graph of this area function is a parabola where the vertex, that you can see the negative b over 2a. So the x coordinate was 20 with a max area of 400. So the maximum area K of this rectangle is 400 square feet. And it occurs when you have a 20 by 20, when the rectangle is 20 by 20, or in other words, when the rectangle is square. Right, that's how we get the max area. Once we deviate from that, then the area goes down. Okay? All right. So, so that was, so what you kind of witnessed was the conclusion of section 2.1. So don't fret. Okay, so now let me kind of do the announcements. Let me kind of backtrack. So the announcements that I wanted to say, so let me see. So this is the top of week 9, right? So exam 2 was due this morning at 9 a.m. Again, with all of our assignments, we can work on them past the due date, but I do want to kind of warn you, we are approaching like the end of the semester. I think that first week of December, that's the hard deadline for everything, right? So I haven't added any more homework or quizzes. That stuff has been up there for some weeks now. Only other things I'm going to add on Pearson are like exams, like exam 3 and part of the final. We'll talk more about the final as we get closer. But again, exam 2 was due this morning at 9. You can work on these assignments past the deadline up until the first week of December, with only a 10% late penalty. So then I'm also aware that exam 2 had like those interactive figures, and they just weren't working for most people. So what I ended up doing this morning, it allowed me to like remove those questions, and like if you whatever you submitted, like if it basically gave you credit for it, right? And like if you try to go back and do it now, those questions won't be there. And if you submitted something in the past and you got whatever score you got, it gave you credit for it, right? So it is as if those questions weren't even there. So it was like 10 questions out of 27, right? Just do the best you can with that assignment. It's available. You can still earn a 90% or possibly higher because of that augmentation. But I did pull the grades. Like I waited until 9 a.m. this morning to pull grades. I went on and made the change before I pulled the grade. So as long as you did all the other questions, it'll show. If you work on it past this moment, it will update. It will update. You just won't see it. It won't show like on Blackboard right away. How do I get back to my view? That's weird. Like this. But yeah, so again, what I ended up doing, I ended up removing any question that had interactive figures. It was like a total of 10 questions out of the 27. I essentially just gave everybody credit for it. So like if you submitted it in the past, you got credit for it. If you go and redo the exam, it's like it is as if those questions weren't even there. So you don't have to worry about those, okay? Because I know that was like one of those things, and you just have to do the best you can. So again, I'm not going to hold that against you. Just kind of do the best. Try to get everything else submitted. Let me kind of go through the chat. Let me see. Yeah. So there was a question about if we didn't submit everything, it's okay. So the midterm grade is just a gauge of where you are right now. Anything can happen from this point, right? I've had students that were doing fine and then they fell off. I've had students that were bombing and they just did a 180 and brought it back. And then the other two cases were people that were fine, they stayed fine. People that were poor stayed poor, right? Um, so again, the midterm, and I'll get that grade loaded. So right before I think my 2 p.m. class, I finished pulling the raw data that like off of Pearson after I omitted those questions. I pulled the raw data, so I have the raw data. I just need to like crunch the numbers and load your midterm grades. And so my goal is to get that loaded by before the end of the day. And then next time, like on a Wednesday, we can like when we link, if anything looks out of order, we can talk about it and like take that time to make sure things are in order. So I talked about the interactive figures and how we're addressing that. Yeah, if you're just getting access, it's okay. You can still earn up to 90%. Now, if you are like going back and like doing old assignments, my recommendation to be savvy with your energy, do the old exams first. The exams are like 80% of your grade. The quizzes are 10% and the homework is 10%. So the homework is like the quizzes are like 5 questions each, so that's a good amount of work. The exams are the most challenging, but that's the least amount of work and the most amount of points, right? The homework is a lot of work and minimal points. So if you're finding yourself having to go back, my recommendation is to do the exams first. It's gonna be the same thing when we get closer to the final. You want to just make sure your exams are in order. That's the bulk of your grade right there. And then if you just want to go back and work on quizzes and homework, then that's your prerogative. But the main thing is you definitely want to make sure your exams are in order. And also, all the way up until that first week of December, you can submit any assignment, old exams, old quizzes, old homework for up to 90%. Right? So even though they were due, you can work on any of those assignments. Yeah, you should be able to get 90%. Okay. Okay, so what I think I will do now is, okay, I'm going to stop the stream and I want to work on some of the homework from section 2.1. And that'll bring out some of the concepts that we talked about earlier that I know that you all may have missed. It is in the stream. You can like watch this recording and you'll see it. But let me stop the stream and I'm gonna start a new one that's focusing on the homework for section 2.1. Yeah, I think that's well. I don't really have to do that. Actually, yeah. Let me do that. Give me a moment. I'll go like this.